Thank you, everybody who is joining us today. I'm excited to introduce our speaker, Thomas Haver. Thomas is presently serving as a test automation architect. He leads a team of testers, ops engineers, and production support analysts in the adoption of DevOps practices. Previously, he led the enterprise automation support of 73 applications at Huntington National Bank that has encompassed testing, metrics, and reporting, as well as data management. Thomas has a background in physics and biophysics with over a decade spent in research science, studying fluorescence, spectroscopy, and microscopy before joining IT. I will let Thomas clarify those because I'm not super familiar with them, but Thomas, thank you so much for leading the way today, and I will give you the floor.
Yeah, thank you very much for that kind introduction. As is requisite for any of our Zoom meetings, first, can you hear me and can you see my screen?
Yes.
So it's definitely a tongue twister, fluorescence microscopy and spectroscopy. So you flip the U and the O there, it causes some issues. So thank you all for joining me today for this talk on test automation. As you note from the rising and falling Thanos here, this is going to be a thematic presentation. And that is because for those of you who are in the Central Ohio area, you may be familiar with the Stir Trek Conference, which is a local tech conference held every year at a movie theater. And they show the latest Marvel movie at the end of the conference. And so I try to theme it according to what movie's being shown whenever I was presenting. So you get to see a lot of Marvel characters throughout. So what we're going to learn about today is some of the core concepts around implementing test automation for a team or an organization, and the associated needs for those teams to make sure that it's long-term successful. And that can involve selecting the right framework and tooling, scheduling it in as part of the SDLC, adhering to more rigorous quality standards to make sure that the test automation is of like long-term like successful criteria associated with it. And I've included at the end, but not within our actual talk today, some additional material on metrics, because I did not warn you up front that we were going to be talking about math. I'm not going to scare you with it just yet. So I can save it for part of the Q&A component. So a little bit about myself. If you're interested in contacting me after this, I'm available on Twitter. It's my handle there, as well as I have a tech blog I maintain with members of my team called Red Green Refactor. As was mentioned, I was a scientist for about 10 years before I jumped into IT. I'm also an avid board gamer. I own more than 2,000 board games that take up an entire room of my house. I'm also an evangelist for Ruby Cucumber that led me down the path of adopting a lot of these BDD practices, some of which we're going to talk about today. And of course, I have an adorable cartoon family. There's my wife and my 2 kids. So let's sort of set the ground rules with some shared understanding when I talk about the strategy and tactics of automation. So when I say strategy, what I mean is a plan of action or policy designed to achieve a major or overall aim, whereas tactics is the art of or skill of employing available means to accomplish an end. So for instance, for those of you who saw the Avengers Infinity War movie, Star-Lord here had a great strategy for defeating Thanos. However, his own emotional tactics ended up costing the team, and Thanos was able to snap half the universe. So even though you may have a good strategy, if tactically you do not carry it out well, you can end up with trouble. And so we're going to look at both sides of that from an organizational perspective, good strategy and good tactics. And for that, we'll actually look back in time. So the problems we are faced today in the automation space are the same ones that have been faced 20 years ago. In this case, I took as reference a blog from 2004 that was actually posted by Alan Page. He's one of the more sort of famous people in the testing community, talking about the IE testing matrix that they had to concern themselves. So every time that they needed to make an update to Internet Explorer, Microsoft had to concern themselves with all of these testing variables, the Internet Explorer version, the versions of Windows that you have, and then you add on top of that, they had 36 different language binaries for every change that had to go in place. So these number of combinations make it near impossible for even a company as large as Microsoft to fully test their application before deploying it. And for those of us who used Internet Explorer in that era, especially IE6, know that it's an absolutely disastrous application and very difficult to work with. So how did they actually address this issue? What we refer to today as persona testing, which we'll learn about a little bit down the line in this presentation, is something that they adopted early on. So they realized that they can't test every single combination. So they took a more risk-based approach. They looked at the combinations that actually mattered, as in the versions of IE that actually were present on those versions of Windows. And they grouped together common browser and OS combinations into buckets that matched customer profiles. So that way they were able to more limit their scope of testing, while at the same time being able to test a good number of combinations that represented their user base. So even with all the resources available that they may have, it's still impossible to test everything. So you always have to adopt a sort of risk-based approach to testing. The promise for automation has remained the same largely for the past 20 years through the different tooling that's been made available, that it's going to save time and lower costs while raising quality. I mean, this is what I've been charged with multiple times going into organizations. They want automation in place where there is either no automation to date or they had prior failed attempts. And by the way, in implementing this automation, you're not allowed to affect project delivery dates. So how do you actually achieve this seemingly impossible task of helping to save times while not impacting the team's ability to deliver? So what we have to do is we have to take the approach that, all right, the organization may not have necessarily the right people, the right processes, or the right tools in place. Oftentimes when people talk about test automation, they want that sort of magical solution where you sprinkle the fairy dust over top of an application with automation and it's successful. Here again is something I take historically, from the early 2000s with Alfredi Dustin's implementing automated software testing, where as an application grows, the cost and time to deliver increases. Your concomitant test coverage and quality drops. At a certain point, if you implement automation, then magically the reduced time and cost to test it at the same time of increasing your quality and test coverage. But it's not just simply of choosing an out-of-the-box tool, selecting a vendor, or bringing in someone who knows test automation and immediately being successful. You have to take the same care with automation as you would for developing an actual application that your customers are going to use or your internal employees are going to use. You want to take that same care. If you do not, then you're going to end up with a mess that you end up having to rework or throw away entirely a few years down the line. So when I work with teams and organizations, I generally put my strategy into these buckets of what is the scope of our work? What does success look like for us? What are the individual objectives that you're going to have for the test automation? What is the approach that we're going to step by step actually adopt test automation, the framework and tools that you will select for it, the environment under which you're working in, the scheduling component of making it part of SDLC, and then lastly, and I think most importantly, the technical skill set of the people you have in place. So these are all core components to our strategy. Let's talk about the approach first and foremost. So one of the challenges that is commonly encountered in working with people is once they go in and you try to implement automation within a team, they're not sure of what they can and cannot automate, and they're also not sure of what is actually possible or not. So what you want to try to do is standardize this process. So when you have people going off for tasking sessions, whether you're working in the agile environment or you're trying to build up a big book of requirements working in the waterfall space, you want to have a set of criteria. In this case, I have a simple checklist that people can use. Here are some sample questions of those, like, is the task going to be repeated and how often? How much time do you estimate could be saved? Are the requirements low risk, stable, or is it something that's going to change because it's a content managed system? Is it subject to human error? Is it time consuming? Is it repetitive? So you want to try to find tests that are on the critical path. You want to try to find tests that are going to be reused, and tests that are going to actually provide value running weeks, months, and years from now. And standardizing the sort of criteria that someone would use to decide whether or not to automate something is important, because everyone brings in their own biases, their own experience, and what one person says you should and can automate, someone else may say, no, you can't and you shouldn't do it. So this is the first step. You want to try to create the sort of standards in place for your organization. You also need to change the mindset. And from the approach perspective, as I mentioned, we should treat our automation scripts the same as our development code. What does that mean? Well, that means every new test script that you write should factor in the maintenance costs. It's an investment that you are making long-term in that test script. So it's not just the cost of you writing it the first time, it's the cost of updating it for the tooling you have associated with it, OS upgrades, language upgrades, as well as things like documentation, implementation, onboarding. All of these things go into supporting your automation tool. Your automation is another application. Its purpose is just to test other applications or to handle data or reporting. So you need to take as much care as you would expect from any application that you're developing and putting to face your customers or your internal employees. So there are some organizational constraints. And so this is, I realize, working with multiple organizations, that they're never going to be perfect. You're never going to work in a perfect environment where you have total control. So you work within the sort of bounds you're given. So we're always going to be limited by delivery schedule, our project budget, technical skill set of the folks in place. So therefore, we adopt the same risk-based approach that I showed you with that example from Microsoft, such as the frequency of use, criticality, legal risk. We want to try to look for anything that's sort of complex scenarios that require a lot of data and environment setup, where most of the time that people are spending is around the setup and teardown activities as opposed to actually testing. If we can automate the setup and teardown, then we're going to save a lot of time. So in this way, I end up using a scorecard. In this case, I made it as a simple checklist. You can instead do it on, say, a scale of 0 to 10, where what you look at are the individual features or, say, scenarios that you want to implement for an initiative. And you want to set up a number of success factors or things that you really care about. And those can be something that's on the critical path or highly frequent, something that is a legal compliance, something that involves data or an environment setup, something that's we're going to reuse again and again. So and overall, I try to limit an organization to, say, 10 of these factors and have a score of 0 to 10 for each of them. So that means you end up with a score, a rating system that goes from 0 to 100. What do you do with the scorecard? Well, you set the priority of your automated tests with it. So once you set a score for each feature to be developed, you then have that priority list top to bottom about which tests you should work on first. You can also, as an organization, set a threshold that say below a certain value, this is a test that's not going to really help us out long term. And therefore, it's just going to be manual for the first time we put it in, and it'll be left to itself. So these are things that empower teams to work from the most valuable automated scripts as an upfront down to the least valuable, because we're always going to be limited by time in some fashion. So to date, I've talked about like automation and saving you time, providing you that coverage, but there are a couple of misnomers. And this is important not only to state to your team, but to the senior management. So good test automation should enhance testing instead of replacing it. It should help testers do their job instead of replacing them. It's a tool to be used. It should be part of your SDLC, part of that entry and exit criteria. It's not something that's simply automated checks like, oh, is this div present in a web application? Can I click the login button? Those are very simple tests that could likely be handled better with, say, integration tests. You want something that is more complex and matches the user behavior. The test should also be focused and informative, as well as trustworthy and repeatable. What do I mean by this? Well, one of the common issues that occur is test automation will end up being flaky, as in you'll send execution reports on a regular basis from whatever CI tool you're using, and half the test will fail, or maybe 25% of the test will fail. Well, one, it'll take a lot of time to actually go through and do the failure analysis. And two, and this is more importantly, all of your stakeholders, developers on the team, product owner, business partners who are receiving this, if they see failures every single day, they're either going to think that the application is in a bad state. If it is not in a bad state and it's just these test failures due to data and environment or flaky tests themselves, then they're going to stop trusting the results of those tests. So if something is always flashing red, you're eventually going to ignore it. So you need to make sure that your test automation is trustworthy, that when there is a failure, that it's an actual true failure and something to investigate. If it's always failing, then people are going to stop paying attention. So up to this point, we haven't talked about framework and tools, and this is sort of a necessary component that's based upon an organization you're in. Some organizations are more heavily regulated than others and have limitations for adopting of new tooling, whether that be open source or commercial tooling. So I'm going to provide an example here. I'm not saying this is the best. I'm saying this is one example and why this is selected. So here you see an automated test written in plain English. This is Gherkin format, become very popular in the industry, especially amongst requirements analysts. And that's because it takes the format given, when, then. So a context, an action, and an outcome. That actually mirrors quite well unit testing pattern of arrange, act, assert. The point of using Gherkin as the top layer of your automation is that you make it transparent for all members of the team. So that way you don't have to have someone technically know how to write the code to understand what the test is. It also means that the test that you have can be understood by the developers and testers without having to be rewritten in multiple times. The fewer times you have to actually rewrite your requirements or reinterpret them, the better. You want this to represent living documentation about the state of the application. For this particular test, it uses Selenium, which is an open source tool, Ruby, and Cucumber that gives us that Gherkin. So why use something, say, for web applications such as Selenium? Well, the reason for it, and what I recommend for organizations, is you want to try to keep your tech stack as small as possible. A tool like Selenium has been implemented in many different languages. So that means you can ideally align your test base to be written in the same code as your development code for the application under test. This means it's more likely to have support and active participation from developers because the developers will be more comfortable writing tests in a language that they already understand rather than learning a new one. It also means that the tests are more likely to live in the same code base as your development code rather than a separate repo. And so Selenium is powerful in that, great, we can test all the sort of browsers we want. There are integration points for a lot of cloud-based platforms, and low cost, as in no cost for this because it's open source. You are going to have to decide based upon the organization profile that you're supporting, what is the best solution. There are some out-of-the-box solutions like Ranorex that you can purchase that are sort of plug and play. There are other ones open source that you will select, and the support is largely up to the community, and you'll need someone with a little bit more experience to do it. But overall, the message is you want to try to find the framework and tools that best fit the organization rather than pushing the framework and the tools on the organization for what you believe is best. So in the same space, we want to talk about coding standards. So here's another test, a very simple one where we're just confirming, say, money is going to result in predictive search questions coming up. So why do we show this as an example? Well, one of the reasons is we don't want to have people spend a lot of time working underneath the covers, as in like building out new code. We want them to focus on those testing activities. Like that's where the most value is had. So what you want to ideally do is start with these so-called like code Legos, these very simple and reusable steps, like I have here with a few examples. So the one in the center is the user clicks, insert name here of whatever page element I want. This can work with any element on any web page. So think about the reuse. It can work many times within a single application. I can reuse this code on other web applications, and it's done in 5 lines. So this is great because that means the tester is going to spend less time writing new steps, new scripts, and instead they'll be spending it on those value-added testing activities because they get to just reuse this again and again. Another benefit of these so-called coding Legos is we get to move from these very simple test cases you have here that are very imperative style. Again, the imperative style is the how, like how the user is interacting with the system. And you can actually turn those into declarative steps. So declaratives are talking about the why, like why is the user doing this? Like trying to understand ultimately the goal for that user behavior. So you can have all of those little steps that are in the imperative how style and wrap them up into a declarative statement. So rather than having each step describe, I'm opening a browser, I'm going to the home page, I'm entering my username, I'm entering my password, clicking login, and all these steps again and again for every single test, you can wrap that up into a single declarative statement that just says, hey, given the user is on the account homepage. So that way, little steps into one declarative step. You don't have to write any brand new code, and you make it very easy for people to read it. So at this point, I've been talking largely about functional testing and some of the sort of misnomers that people have associated with that. So one of those that we should change the development focus and automation focus for is around the persona-based testing. So Alan Cooper, who wrote The Inmates Are Running the Asylum, said personas are incredibly useful when you don't have easy access to real users because they act as user stand-ins, helping to guide your decisions about functionality and design. So in persona, we look at, say, our different user types. Ideally, you can garner this information from, say, the analytics or the marketing team to try to understand what our end users are doing. So that way we can focus our development to them as well as our tests to them. Personas will end up helping us prioritize those features. So we focus our test cases on them. We are consistent in our support of those particular end users. Rather than writing test cases that are rarely used by our end users, we want to focus on those value-added activities, matching what they do. So having those particular personas in mind will help us out. So here's an example of persona testing in a cloud-based testing platform where for mobile testing, we create personas based upon the device, the geolocation, their network profile, any background apps that they would have, and then we logically group them together. And then we can see based upon the functionality here, you have a nice heat map here, that you can understand where we're potentially having issues in our application based upon those personas, where the size of those squares indicate how many tests we have in the space, and the shading of it from deep red to deep green indicate how many of those are passing. So this will help us understand where we have consistent issues. That persistence is important. So that way the personas become just another variable for testing. It keeps things very simple. So your personas, you should typically give them very simple names like Dave or Sally, and you focus your user stories on those personas. So this way you're able to more focus your testing to things that are going to be providing greater value. So I've talked a lot about functional testing because that is, I would say, the most popular when people talk about automation solutions. But I want to talk about actually more valuable types of testing for you to do from an automated fashion. The first of which is integration testing. So integration testing will run more quickly than those UI-based functional tests. They're more robust than those tests. You have any number of tools or framework that match your technology stack, like Spock, Jasmine, Fitness, Vector, and it's something that's executed earlier in the SDLC. So you can actually spot those problems earlier. So in this way, I recommend adopting integration testing as a higher priority than those functional tests. And if we follow this through, unit testing is actually that fastest method of testing. It's easier to debug. It can be done locally on a developer's machine rather than deployed to an environment, has the lowest cost to fix for it. And of course, whatever your language of choice is, you have a framework that you can use. So you have those layers of unit, integration, and the functional UI testing, where the most tests you should ideally have and the greatest coverage is around unit testing because it provides that fastest feedback for you and is the most robust. So take that as a top priority when you're working on automation. So over the course of my career, I've seen a lot of challenges that people have had from either existing solutions when I came into that org or in the course of implementing it. So I want to say each challenge that I note here is something that I've encountered personally. So I'm speaking from experience, both failure and success. So here's a couple of common areas. We'll go with the automation fire hose itself, which is the title of this presentation. So when people learn a new skill or a new tool, they have a habit of trying to apply that everywhere. Everything looks like a nail if you're a hammer. So everyone ends up trying to automate everything once they learn how to do it, not thinking of whether they could or should do it. Just because a scenario can be automated does not mean it should be automated. Instead, you want to adopt that risk-based approach. So what I showed you prior with that automation scorecard is a good way to help out. Using that checklist to determine whether we should or should not automate is another good step. You build in that maturity into a team space, and then they're going to be focused on writing fewer tests, but more valuable tests, rather than tests that you then have to maintain that are very low value. Another common failure point that I note is data failure. So people will write automation and it will not run in that environment because maybe the test data isn't available, or it's available and it will work in a single test environment, but it won't work in others, and it certainly won't work in production. That limits the overall return on investment we're going to get from each automated script. So what you should do as an entry state criteria for you to work on automation is ensure that it is cross-environment compatible. That means the test data generation and manipulation is an upfront concern. All the setup and teardown activities that a tester would do manually or request out to other individuals, for the backend or source systems, should be set up as automated tasks. So that way each test can run independently, has access to the data that's needed, and when you execute it from one environment to the next, that test will get the appropriate data and it should ideally pass. So think about it just purely from an ROI standpoint. If you write a test and it only works in a single environment, you're only getting that value like 1x. If you can execute it, say, across 3 different environments, you get 3 times the value out of it. And I would say, especially if it can run against production, then you get the most value, because that's where you want to avoid defects reaching. You don't want them to escape to production. You want to be able to have that good test coverage in place. So test data management is an absolute upfront concern. Another one that I previously mentioned were the so-called flickering tests. So like you send off an execution report, half the tests fail, and you send it off and a different number of tests fail, and nothing has changed with the application. So flickering tests are tests that you execute again and again and again, and independent of any sort of change to the application, they will seemingly pass or fail, like no rhyme or reason for it. So what you actually have to do for this is remove those tests. Tests that will flicker green, red should be removed from your suite, and you need to conduct a failure analysis of them. They could be due to the application itself being unstable. It could be due to the environment being unstable. It could be due to data concerns. It could be due to your own scripting itself, that you made some mistakes along the way or you took shortcuts, so the test is not going to run consistently. The point of this is you need to have your automation be consistent. So you would rather send off fewer automated tests in your report than report those false failures because of flickering tests. And you need to investigate them. If you cannot address the root cause of those flickering tests, they should not be automated tests. They should be removed. Your automation needs to be reliable. Another common issue that I encounter are extremely long tests. So I showed you a couple of short gherkin scenarios. I have seen scenarios that are 300, 400, 500 lines long. At a certain point, your eyes just glaze over and you forget what the point of the test is to begin with. It could be a long setup for a single payoff, or it could be validating dozens of things during the course of that test. One of the problems with this, of course, is one, if you don't understand what the test is about, are you really getting value from it? And another, if the test fails early on or say halfway through and you skip the rest of those validations, you've suddenly created a test coverage gap and you have no idea whether those other items are passing or failing without first addressing that failure point. So you created a bottleneck for yourself. What you need to do from a priority standpoint is take unit tests and integration first. They're more quick, they're more robust, faster feedback. UI-based tests, the so-called like functional testing, need to verify end user behavior. So fewer of those tests and more valuable. And they should ideally be focused on accomplishing one goal. You want to keep those tests short. With a number of linting tools that are available in the space, you can sort of limit on a team basis to say, hey, you cannot have more than 10 lines, or you cannot have more than 8 lines in terms of the steps you're going through for verifying that end user behavior. So that way you keep things simple, you keep it verified on one thing, and you make sure that people can actually read it and understand what the tests are doing. Another common issue that I've encountered is automation that is built to reach a done state, reach to the next day, reach to deliver for our sprint or just this project. And later we're going to go back and we're going to fix this up. We'll definitely refactor it later, but there's never enough time and you never go back to fixing things. So people who only build just to get to done, and this applies both to our development code as well as our test automation code, are creating technical debt. And that technical debt accrues to the point of you either need to completely stop and fix your test automation suite or throw it away. This was actually my experience when I worked back at Nationwide, is people were working on suites that others had built and had subsequently left the teams, and they were unwieldy, they were huge, they took forever to execute a single test, and eventually you just had to throw it away and start again. And if you didn't adhere to any good design principles, a few years down the line, people throw it away and start over again. You cannot build your automation on a shaky foundation, no more than you can actually build your development code base on a shaky foundation, because it becomes a maintenance nightmare. And you end up killing off any return on investment you could have from time savings. So what you should do, treat your automation code the same way you would treat good development code. Good practices like dry, don't repeat yourself, KISS, keep it simple, stupid, with scheduled code reviews, code analysis tools, and refactoring sessions. I'll mention a couple of those in a little bit. So you should absolutely include the same standards as you would expect from a good development code base with your test automation. This is how you can ensure that years from now, after those people have left the team and a whole new group have come on board, that test automation suite is going strong, it is consistent, and it is easily extensible. The last common issue that people will typically encounter is making sure that automation is actually concurrent with development. So they say, we don't have time to do it during the sprint. We'll just mark this as a story for the next sprint and we'll skip it. Or the development is done in one sprint and the testing is done in the next, completely disregarding what the actual done state means in the releasable bit of code. So what you should do is bake automation feasibility into the definition of ready, or the entry state criteria if you work in a waterfall world. And you need to have your completed scripts in the definition of done, or as an exit phase criteria as part of that verification phase. By making it part of the entry and exit state criteria, you can ensure that quality is baked into your process. You need to have automation scripts written concurrently with your development code. In the same way we would expect from, say, test-driven development to write a failing unit test, implement enough code to make it pass and refactor, so too with our automated tests. Should we implement a failing automation test, functional, write enough code to make that functional test pass, and then refactor it. So it needs to be ready and execute at least in that environment. So part of those entry and exit state criteria that I mentioned, can include the automated test must execute at least in a single environment before we can declare this card is done and migrate to the next test environment. So scheduling is always a big challenge with automation. How do we actually make sure that it's going to be done concurrently with development work? And how do we make sure we're doing it right? So this is where I draw largely from the work of Matt Wynn and Aslak Helsoy. So they're the authors here of the Cucumber book and Cucumber recipes. And they're primarily focused on BDD, behavior-driven development, as in writing your development code from the perspective of the user always in mind, and collaborating with multiple members of the team to reach that shared understanding. In the BDD practice, you go through a phase of discovery. That's where the team gathers together to understand what is the work to be done as a group, rather than being sort of tossed over the wall. Like, hey, our business stakeholder said, this is our need. Our business analyst translates that into a form of acceptance criteria and throws it over. Developer, do this. Developer throws over the code. Tester, you need to come up with test cases for this that I just put in place. No, this is all representatives working together up front to define those requirements. You then formulate those requirements into executable specifications, which become our test cases that we then automate. So let me walk you through this process to make it a little bit more clear. And here's a great recommended event that teams can adopt to help support automation. It's called example mapping. In an example map, you start with a single user story. You have representatives from your team that can be product owner, requirements analyst, developer, tester. As long as you get sort of like the different focus areas of the teams together and represented in that meeting to talk about a single user story. In a time boxed session, you will generate a number of business rules, which you're going to write on blue cards. This is the business logic that developers will actually implement. For each business rule, you are going to come up with one or more examples that illustrate the business rule. These are your specifications. They follow the end user behavior, and they're the foundation of your initial test cases that ideally you can automate. If during the course of that time box session, people have questions that no one in the room can answer, you're going to capture that information on red cards. So this empowers the team because they will understand what needs to be accomplished and what's still as an open action item for us. So you end up creating that shared understanding on your team. Your examples become the user scenarios that you can automate. The rules, the business logic, become the acceptance criteria the developers can take with them. And because you've empowered the team, you reduce rework or large or unclear stories. What I mean by this is, if you have way too many red question cards on your example map, that is a good indication that development work is not ready to begin, and you need to resolve those questions before the team is comfortable taking it into the sprint. If you have way too many blue business rules underneath a single user story, that is a good indication that that user story is too dense and needs to be split apart into 2 or more stories for the team to get it done in the time box they are given. If you have way too many green examples underneath a single business rule, that is an indication that that business rule is too dense and needs to be split apart into 2 or more rules. So this teases out all the details and breaks down stories into its component parts that are able to be developed and tested. So this is why example mapping is excellent for supporting automation and ensuring coverage. So let's talk a little bit more about maturing the state of our automation by implementing some quality standards. So this, in my opinion, is more difficult than actually putting together any sort of framework or conducting training. It's getting people to adhere to your standards and practices. One of those that I recommend is regression review. So if you're working in sprints or you're working in waterfall, you will typically have a regular release cadence. What you want to do in the regression review is have your test lead or whoever is representing QA from that team compile a list of all those new release scripts and the regression scripts. You're going to have production support provide you metrics on the incidents you had for that application, for that release, and any release prior. We want to look at those problem areas that our users are unhappy with. We want the business to provide metrics on application usage broken down by feature. It makes sense those features that provide us the most revenue or the highest use are the ones we want to focus our test coverage. And lastly, the app manager or product owners can provide a list of the upcoming projects with the high-level feature changes, so you know what's going to be deprecated, what's going to be modified, what's going to be added in. Having these 4 representatives come together will then allow you to decide, all right, for our new regression scripts, what we've identified as our examples, these should be added into our formal regression to be executed on a regular basis. These current regression scripts no longer fit the state of the application or provide little value, so we're removing those from our regression. So constantly pruning your automated suite in this fashion to ensure that your regression is up to date, and make sure that your regression represents living documentation, the current state of application behavior, and you're executing those most valuable features rather than just having a gigantic test suite. Whenever someone comes to me and probably tells like, oh, we have over 1,000 test cases automated, I'm like, that's great. I could also write 1,000 test cases that are junk. It doesn't mean that they actually provide value. Like, we need to have an evidence-based decision to make sure that we actually have good automated test cases. Regression review is about making that evidence-based decision. So you have areas where you have defects, you have areas where users are most frequently visiting, you have your roadmap in front of you, and you understand your current state. This will allow you to make that informed decision. There have been a lot of superheroes and a few supervillains shown thus far. My superhero, though, is not part of a Marvel universe, but I have him here with a cape. He's Martin Fowler. He said, I'm not a great programmer. I'm just a good programmer with great habits. So too should we expect our test automation developers to have good habits with code reviews and refactoring. So code reviews, the same expectation we have for our development code base, so too should we have for our test automation, which means that for the team, those test automation scripts should be understandable by the team. In a code review, you need to make sure that they represent the state of the application. You don't end up duplicating effort that's already present, that you've identified upfront all of your data needs and object needs for working with that application. And whatever working agreements the team have around traceability, formatting are all met as a part of this code review. So there are a lot of tools out there like GitLab or Azure DevOps that have code reviews baked in as a requirement to actually merge the code in. Do the exact same thing with your test automation code. Require code reviews by other members of the team to make sure that you adhere to the standards. So that way they're just not putting in junk just to get to a done state. It's something that will maintain quality months and years from now. You should also conduct regular refactoring sessions. I recommend a once per week, 1 hour time box session with everyone who works on test automation within the team, focused on those same principles that Martin Fowler talked about: maintainability, extensibility, and domain knowledge. When you're looking at refactoring different areas of your test automation, your guiding principles are we improving performance? Do we have non-orthogonal design built in? Are we duplicating ourselves anywhere? And is there any sort of outdated knowledge that needs to be removed or just simply updated? These are the guiding principles that drive us. But just telling people to host a refactoring session is not actually enough. People will sort of wander around. You need to provide them with guidance so that way they can be successful. And this is where you formalize refactoring sessions. You have a leader, someone from the team who's going to take ownership over scheduling that meeting, the delegation of the action items from the session, selecting the focus area for that time box session, and any bug reports that are generated when they come up and find issues. You should also have an automation guide present. This is someone that I recommend comes from outside of the team. So we have a tendency to sort of have blind spots to our own work. And it actually applies largely to teams as well. We have blind spots to areas of the application where it needs help. So if you have an outside Oracle, that person keeps track of that live session and is there to help out with any action items as needed. They're there as that technical guide in case the team runs into issues. They will also keep track of that improvement status report, say from the code metrics that's been run or what has been accomplished in that session. And I mentioned like a focus area, we need to provide guidance to them. So good focus areas that you can rotate on the selection could be your code metric report, a feature item that's actively being worked on, say in that sprint, overall project release that you want to look over, your regression, or just a more recent like CI report where you're noticing some logging errors occurring. So having these regular refactoring sessions and formalized in this manner will help ensure that everyone's engaged, that you have senior members working with those junior members to share that domain knowledge, and you make sure that as the size of your suite grows, your quality remains the same or improves rather than goes down. So in summary, what did we learn today? Well, a few things for you to take away. One is you should focus on the fastest, most robust tests. You should create UI and end-to-end tests as needed. So your focus should always be unit, and that service level, then UI, and lastly, the end-to-end. You should build your automation based on the probability of failure, impact on business, and the complexity of those scenarios. You should always take into account the budget, schedule, and technical skill set. It limits your path forward. So never set the sort of fantastical solution if you're given all the time and all the money in the world, because you're never going to achieve it. First, understand the bounds with which you're given and work within those to generate as much ROI as possible. And then celebrate that success, institutionalize it. So that way you then end up getting more support to accomplish more in the future. So it's not about reaching that goal state immediately or within 3 months. It's about building steadily, iteratively over time, the success, and making sure that as you're building it, it's sustainable for the long term. So at this point, I'm open for questions. If other people also are interested, I have the metrics slides after this. I want to give people an opportunity to dip out if they don't like math at all. Thank you very much.
I have a question. My name is Siva Prasad. I'm a SAP tester. In SAP, most of the times they don't implement the automation, test automation. We do manual testing. So have you ever done anything on that side on ERP applications?
You mean SAP?
Yes.
I personally have never worked with SAP applications. However, there are a number of commercially available tools out there, like NetWeaver, that you can use, or there's some open source tooling. So what I would recommend you do is come up with a set of critical success factors, as in like these are the solutions that automation is solving for us, and understanding the limitations of your organization, as in like sharing of, say, PII that you would care about, whether you can use cloud-based or you have to have a on-prem install. And then from those factors, examine the various open source and commercial tools available and select one. If you're interested, I can provide you sort of a sample evaluation sheet that I use for cloud-based testing platforms, just so you can see and create one for yourself. So that way you can select the right tool for the job.
Sure, thank you.
Hi, I have a question. In the beginning, you mentioned one of the downfalls of test automation is sometimes people believe, or companies believe, it's as simple as bringing on a third-party vendor or bringing in a certain skill set. And as you explain in your presentation, it is so much more than that. So in your experience, when you come on and consult with a firm, are you teaching, are you, I guess, leaving them with the knowledge that they can maintain that? I don't know if you offer reference services to maintain that process, but I'm wondering, when you finish your process, does the organization have the in-house skill set to continue? Or do you recommend, whatever gaps are needed so that they can maintain whatever, you lead them with?
Yeah, so that's a good question. That's sort of a whole other presentation I have, but the short answer is,
sorry.
You need to ensure that those teams are self-sufficient, that you're supporting. So you're not doing it all yourself. So my team, say when I was back at Huntington, it was 8 strong. There were 8 architects, myself included, and each of us had oversight over an entire business segment. So like commercial or digital or lending. It's impossible for 8 people to work on 73 applications and build out the automation for them. Just not enough time. So what you need to do is to teach people how to fish for themselves. So that's why for each application type, it's like web, desktop, database, mobile, mainframe, what have you, I have a set of core training that you teach people, and this is required. And the cool thing, if you try to, worried about the project deliverables, is you actually make the training to their active project work. So you do it as one-on-one to active work, so they're always making progress forward. And I would say as a psychological effect of that, if they're learning to their active work, they're already likely comfortable with their own application. They have the domain knowledge in place. So you're marrying the technical ability of the person who's training them with the domain knowledge of the person who's learning. So you get that sort of cross-pollination of knowledge sharing that occurs, and they're making progress towards their project deliverables with the expected outcome of, once that core training is complete, that they can handle it on their own. That project level work is done on their own without any sort of assistance that's needed from the outside. So this is why also, and I could go into a lot more depth as a separate, sort of workshop I do around building frameworks. You should build the frameworks to minimize the amount of time that people have to spend underneath the covers working on the so-called infrastructure. You make it so that it's easy to write tests, that Gherkin format in the top layer, and minimize the amount of steps or associated modules that they would have in support of it. So this way, you lower that technical hurdle for people to be successful, and you minimize the maintenance costs. So this is how you make those teams be self-sufficient. So actually, like as I was giving this talk here, another member of my team he's got a full day of one-on-one trainings with various people for one of our current engagements, where he's helping them be self-sufficient across multiple teams.
Thank you.
I don't have a question. I just wanted to comment that your presentation was amazing, and I loved all the superhero graphics that you used throughout. Did you design those yourself?
This is from 3 separate people, actually no, 4, I would say. So the initial, the cartoons with me and my family, that is done by Nate Lovett. He actually does that for every speaker at StirTrack. That's their speaker gift, is they get a caricature of themselves framed. The other 2 for putting together the initial ones you see on those transition slides, it's myself and Josh Russell. Josh is a member of my team. And then the one you're seeing here, the similar like line tracing that's done by Damian Sinadinos. He of Ineffable Solutions. He actually does this as part of his service offerings. Is he will take existing presentations, whether they're for tech or not, and he will go through and update them thematically. It can be very cartoonish like I have here, or something that's very professionally done. So I try to theme all of my presentations to make them a little bit more excited, because if you're just showing some code on there, like it can be great for a few developers, but most people just start looking at their phone halfway through.
Yeah, it's very great. Thank you for sharing.
Hey, I have one more question on when you said in the presentation that some of the code to be reusable for the future developments or for future maintenance purposes. Do you mean the complete code of the code, or part codes like you gave an example of when you go to so-and-so page, what is the next result of what is happening there? Those kind of bits and pieces which you can reuse them.
So I would say sort of 2 layers to answer your question about the reusability. And I'll go through a practical example. I'll go back to say Huntington again. So of those 73 applications my team had to support, 42 of them were web applications. There was a single base framework that was used for all 42 of those applications. And so you build a framework that can work for a given application type and be used for any application type. And you do that by implementing the functionality that matches the core user actions. So for web, I think that there are around like 40 or 41 like core user actions for how someone would interact with a web application. And you use that as your code Lego. And you go through this similar with like mainframe, it's actually much smaller. There's only about 13 different core actions for how a user would interact with the system. You repeat that for mobile, for desktop applications, database, and then you can make it reusable. And then to your second part, all right, within an application to make it reusable, like, so a lot of say either the navigation or the validations are going to be similar in nature. Say for instance, actually logging into an application, whether it's desktop or database, well, not desktop or web, it's going to be the same. So you put in place the code in such a way that it's easy to reuse and for you to package it up into a sort of a nested step that is summarized as a single line, and that is custom for that application, but it is reusable by that application, and you keep those in place. What I recommend in my separate BDD training is actually for the business analysts to identify what those core behaviors are for the system that then become our standards. Similar processes that users would go through that you can summarize, and then you build out your automation that can be reused for a given application. It makes writing automated test cases as easy as putting together a Lego.
Understand. Thanks.
Hi, Thomas. I have a question also. The presentation was really good. Regarding your the level of testing, like the unit testing should be there, as it means like testing from the lower layer, and the integration testing should be there. But in our application, it's like when you go to the integration testing and work with the prod accounts, it's like the main problem that people usually face is with the billing scenarios. Like we deal with the prod accounts and we have to update the test data because we have different kinds of account. Like a user should have an amount due, a user should have a past due, but after a month that test data is gone. So we have to update the repository with the test data. So is there any other way that we can, either we can minimize these kind of scenarios, because we are also dealing with the credit cards and with that real cards or gift cards regarding these billing scenarios. So in integration testing, our test cases kind of minimized because of these constraints that we have.
So in that way, I go back to looking at the ultimate value you get from it. So if you don't actually have access to do the setup and tear down of your data, like, are you truly getting value out of those tests? When you look at the amount of time that you have to spend to manually sort of set that up, or you have failures that happen intermittently because, say, they do a database refresh. So what you need to do is that up front is build in the data setup and tear down. And in some cases, you don't have access or, total control over the source system. And if that's the case, then you need to set up a separate repository for your tests so that you can maintain the data from there. You can also use certain things like service virtualization that will help you out, or there are some TDM tools like Informatica that you can use to help support your initiative. It's generally, it's just about that, cost benefit analysis of, if we get full control and we can have it, is this the ideal state? How much will it cost for us to get to this? If not, is the cost of us having to do all the setup and tear down on our own manually more than the value of the test? And maybe then we just remove that for risk, or we only do it occasionally for risk because of compliance reasons. So that's really like the analysis you have to perform is, if we were to set this up perfectly to have it automated across all environments, full control data, it costs us this much. If we can't do it, how much is it costing us to do it testing now? And if it's too much, then it's a test we should not run.
Okay, yeah, got it. Thank you.
All right, any last minute questions for Thomas? Thomas, thank you so much for all of your information today. I agree with Stephanie, your presentation was awesome. We will also send out the recording once it is available, along with the survey. So please feel free to share any feedback or suggestions for future events, including topics you would like to hear. Also let us know if you or someone you may know would be interested. Sorry, I just gotta, can everybody hear me still? My connection seemed to have gone out. Okay. Let us know if you'd be interested in hosting a webinar yourself, or if you know someone who might be in your own area of expertise. You can email us at experience@selectgroup.com. We look forward to you joining our next event for our next technical webinar series. And thank you again for joining. Have a great rest of your week.
Thank you. You too.
Take care, everyone.
Thank you.